to break free. Oh, ready for the videoing. Sorry, I didn't realise. We'll, oh dear, got to do some cleaning there. Answers to the mechanisms questions. 3 separate videos, be 3 separate short videos with the answers. Free radical mechanism video, electrophilic addition, nucleophilic substitution, all year 12 focused, and we'll have the answers. I'll see you after the edit very soon. So welcome to the answers to free radical mechanism questions that were set in connection with the explanation about free radical mechanisms. A, B and C up on the board right now. 3 fairly straightforward questions. First one, classic initiation. Ultraviolet triggers the breakdown of a halogen, bromine in the case of this question, into 2 free radicals. I've done the dot, sometimes you will see them without the dot, depends on the question of the board. The second one, in order to produce HBr from 2 free radicals you need 2 free radicals. One of them has to be a bromine atom, because the free radical is a separate atom rather than the molecular bromine, and it's going to have to be a hydrogen radical, which is a hydrogen atom, and they will join together, make HBr, make a bond between them. The third one, bromine reacts with cyclohexane. Cyclohexane represented by a hexagon. Don't forget there are 12 hydrogens, and if you are going to put that on there, you have to think, okay, yeah, there are at every carbon 2 hydrogens, so one of them has been substituted by the bromine, because it is a substitution reaction like it says up there. So there must be, if this is a propagation step, which it is, then there has to be the formation of a replacement radical for the one that was consumed, and so we get bromocyclohexane and a hydrogen radical ready to go off and do some more reactions. That's A, B and C. We've got the horror of the mistake in D to deal with. That'll come up after the edit. I will see you after the edit. Bye bye. Bit of a, not an error, it's just I thought I'd asked a different question when I wrote it, and I meant it to say starting from bromocyclohexane, but I said I put the word only in accidentally. So yeah, the whole thing becomes a little bit unrealistic. I mean, the actual answer would have to be that. What would trigger that we don't know, because ultraviolet won't do that, but it's bromine coming off. It's not realistic. So if you reacted that with some other radical, what you could then get, which is what I was trying to get at with the question, is that what you can do is that you can form that bromine radical, and that then has 2 hydrogens there. Don't forget there's 1 hydrogen there already, and that's what I was trying to get at, but I asked the question wrong in the sheet and doing it too quickly. So technically, yeah, practically that's the wrong answer, because it doesn't happen like that. Here is what I was trying to get at. Then we've got E and F. We'll come back, I'll wipe the board and we'll do E and F. See you in a moment. So here we are with E and F, the last 2. Got to produce bromocyclohexane from 2 radicals. So what you've got to do is a termination step where you've got to bring together 2 radicals. So really, and it isn't the only answer, but it was really pointing you towards putting a bromine radical with the cyclohexyl radical. I seem to always put the unpaired electron in the same place, doesn't have to be there. Now, another legitimate answer to the question is you've got a bromocyclohexane but with 1 hydrogen missing, and you put a hydrogen on it. Not what I was getting at, but it is a legitimate answer to the question. Now F, well, how do you get to form C12H22? Well, you have to kind of think, well, what could you possibly have done to get something C12H22. Well, quite frankly, it's quite straightforward really, because C12 is 2 cyclohexanes, because hexane is obviously 6. So if you put cyclohexane, now cyclohexane C12H24, well, if you had 2 of them, that's an error, C6H12, I'm sorry, that's what I meant. C6H12, and you put 2 of them together, you will get C12H24. You've got to lose 2 hydrogens, but that would be the link between them. But also, if you went, oh well, we'll put that, and we will react it with another one of those, the bond will form where the 2 unpaired electrons are, and you will end up with 1 cyclohexane ring joined to another. And if you count up the number of hydrogens there, I do dots to count hydrogens, 22 dots, C12H22. So it is 2 cyclohexyl radicals joining together. And that was the answers to the free radical mechanism questions. I'm sorry about question D. I'll try and be better next time. See you on the other videos. Bye bye.